So we first have to discuss this concept. Composite function, the composition of functions. What is a composition of function? What do you think that means? Not a collection, because that means they're all independent. This one, what it means by composition means a function within a function. Think of what composite materials are. They're different materials that are combined that are not integrated into one. That's what we're looking at here. Typically, these are called the Fogg and Goff methods. And they'll make more sense what I'm talking about in a second. So let me just jump straight into an example here. Let's say the function f of x is 2x minus 5. Well, yeah, it deals with functions.
But we're looking for f
Of g, right. And then let's define g of x as x squared minus 3x. Let's not this. Let's just do x minus 3. Let's do something easy first. The composition of functions is I can have one function inside another function. The way this is read is f of g of x. And it's like one of those Cupid dolls. It's built up. So it's f of g, which means I have f of g of x. So that's what it means when you see it this way. Now, what does this mean if I have two functions? What this means, since my g of x is the input variable to my f. Yeah, so anywhere as I have an x in my f function, I put a g of x. That's what that says. But what is g of x? G of x is x minus 3. So I'm taking this function and plugging it inside the other function, hence a composite function. So this becomes 2x minus 6 minus 5, 2x minus 11. That's the f of g of x. You've seen it before. So that's the Fogg method. Goff means I have g of f, so it's g of f of x. So that means the f is the input function to my g of x. So I take my f function and plug it anywhere I see an x. So it's f of x minus 3. Anywhere I see an x in my g function. But what is f of x? 2x minus 5. That's 2x minus 5 minus 3. Don't forget that part. Negative 5, negative 3 is negative 8. So that is my Goff. It's just how you interpret what it's saying. Okay, let's look at example 1. Because example 1 has 4 parts to it. It defines f of x as 2x minus 5 and g of x as x squared minus 3x plus 8. The first one, the first question says find these functions, composite functions. So knowing what this means, it's f of g of x, which is. So what I do is, since g is the inside, I take the equation of g, anywhere I see an x, I put it in there. So it's x squared minus 3x plus 8. Then it's minus 5. All I'm doing is replacing that function inside of x. Distribute 2x squared minus 6x plus 16 and combine like terms. So there's my f of g of x, my FOG. Yep. And this other one says I have g of f of x. So since the f is the input, whatever I have here, anywhere I see an x, I put that in there. So that's 2x minus 5 squared plus 8. Yeah, so I'm putting anywhere I see an x here, I put my function of f of x. Now I got to work it out. So since that's squared, I have 2x minus 5 times 2x minus 5. Two x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 is negative 10x. Positive, negative is a positive 25. Negative 3 times 2 is negative 6x. Negative is a positive. 3 times 5 is 15 plus 8. So we only have 4x squared. That's that one. Negative 10, negative 6 is negative 26 x's. 25 plus 15 is 40, plus 8 is 48. So there's my composite function of g of f of x. Any questions about that? What if I had the same question, but I'll make something smaller here. I'm gonna put a number in there. Actually, it makes it a lot easier. Because remember, what this one means f of g of 2. So with this, we first have to find g of 2. Once we find that, we plug it inside the f function. So it's 2 squared minus 3 times 2 plus 8. 4 minus 6 plus 8. 12 minus 6 is 6. So that's g of 2. Where does that go? Since that's my input, now this goes into my. So that one's going to be 2 times 6 minus 5. 12 minus 5 is 7. Or I always do it. Makes it much easier. It's much easier when we have a value. So let's go and do the other function. So this one is G of F of 2. We first find what?
Uh,
F of 2. The F function is 2x minus 5. So it's 2 times 2 minus 5. 4 minus 5 is -1. So that's my input. That goes inside there. So I have G of -1, which makes it -1 squared, 3 times -1 plus 8. -1 squared is 1. Negative and negative is a positive. 3. 11 plus 1 is 12. So it's much easier if you do it that way. How about if I gave you the GOG of 1? G of 1, right? So G of 1 is 1 squared minus 3 times 1 plus 8. 1 minus 3 plus 8. -2 plus 8 equals 6. So that goes in place there. So now I'm looking for G of 6. 6 squared, 3 times 6 plus 8. 36 minus 18 plus 8. -18 plus 8 is -10. 36 minus 10 is 26. So that's my answer. So you can make composite functions of the functions themselves. You can have G of G, GOG, or you have FOF, F of F.
one part of an equal to.
It's not, this is -18 plus 8 is -10.
Oh,
And the last one is using the same functions. Find FOF. So this is F of X. What is F of X?
actually, it's too expensive.
So I'm putting the 2x minus 5 inside there. So anywhere I see an X, what do I put in its place? 2x minus 5. This is my input. Remember, F of X is 2x minus 5. If my input is 2x minus 5, that goes right there. 4x minus 10, 4x minus 15. There's your answer. That's it. Example 2. If f of x equals square root of x and g of x equals x minus 3, find f of g and then g of f, and then tell me their domains. Then tell me their domains. So this first one is f of g of x. And g of x is x minus 3. That's my input. I put this inside the f function, so I have square root of x minus 3. That's my FOG. What's the domain of that function? Well, what's the graph of square root? Starts from 0. If I shift it, what direction is this going? It's to the right. So my domain is or x is greater than or equal to 3. G of square root of x, which becomes square root of x minus 3. So the domain is really only this. What's the domain of square root of x? 0 to infinity, or x is greater than or equal to 0. F of x equals 1 over x minus 2. G of x is 5 over x. Find Fog and Goff. So this is f of g of x. This is g of f of x. So g of x is 5 over x. I plug that in any x I see in my function f. So it's 5 over x minus 2. I have to combine the two numbers on the bottom, adding fractions, so common denominator. So I get a 5 minus 2x over x. You have a fraction over a fraction. So take the top fraction, leave it alone, and flip the bottom, which makes it x over 5 minus 2x. And the domain is x cannot equal 5 over 2. I can use any x except what makes the bottom equal 0. That's my domain. F of x is 1 over x minus 2. So we have 5 over 1 over x minus 2. It's a fraction over a fraction, so we get 5 over 1 times x minus 2 over 1. Denominator is 1 on the bottom, so we get 5x minus 10. No restrictions on my domain. I gotta hurry up because we only have a couple minutes left.
Oh, wow.
Now, the last two questions deal with decomposition. If I have h of x is made up of 2x minus 3 to the 5th, find f of x and g of x such that h of x is equal to fog. So which one's the inside function of this one? The inside function is, that's my fg, is 2x minus 3. That's my g of x. My outer function is x to the 5th. I just plug that in there. I got that. And the last one, same thing. I have 1 over x plus 3 cubed. Find f of x and g of x such that h of x is made up of fog. Yeah, so the inside one would be x plus 3. And what's the outer function? Yep. So take the equation that's the inside. That's my g of x. Put an x there, and there's my f of x. Boom, we're just done with that. That's all chapter 2, section 2.